we are going to use a co-current heat exchanger, and this surface area of heat exchanger is going to experience high amount of heat transfer according to the formula that we have talked about. Okay, when the differential temperature is higher, amount of heat transfer at this area will be high. But when it passes through the heat exchanger at the last section of the heat exchanger, it's going to be decreased. And it's not good for effectivity because we haven't used the effectivity, the most effective way of the available surface for heat transfer. Okay? We said that we want to use the whole surface available as effective as possible. Okay? That's why if we are able to change the direction of heat transfer, it can easily increase the effectivity of the heat exchanger. So, if we consider the countercurrent flow, here it would be, for example, 19, and here it would be 16. It will provide better uniform differential in temperature for heat transfer. Here it would be about 40 degrees of Celsius, and here it would be about 30. That's why in most of the cases we prefer to use countercurrent flow in heat exchangers. Okay? And we have other types of heat exchangers that sometimes they use cross flow. Okay? Suppose what's the difference when we use cross flow? A cross flow means that in a situation that the hot flow is horizontal and the cold flow is vertical. And we can check if the temperature difference provided in this way is uniform, and we are going to use in the most effective way of the available surface, you can use cross flow heat exchangers. But in most of the cases we can see that counter flow is the best one. Okay? You remember the formulas? In all of conduction, convection, and radiation, the temperature difference and surface area was the most important items for choosing the best one.
I think here in this slide there is no surface area.
In cross flow, it depends. It depends on the design and of course the fluids. Okay? In plate type heat exchangers, in most of the cases they use counterflow because they want to use all the surface area available. But if we want to classify the heat exchangers, we can say that the shell and tube heat exchangers are the most common heat exchangers, and we are going to see how many types of shell and tube heat exchangers do we have. Look at here. For a shell and tube heat exchanger, we are going to provide an area for shell which contains the tubes. Okay? And the passage of this tube can show us what is the flow direction of heat transfer. It can be co-current, counter-current, cross-current, or in some cases mix. We can use all of these different flow passes of the hot or cold medium. Okay? And by using softwares, we can check if it is effective to pass the hot medium, for example, over the tubes in cross flow or in counter flow. But what's important is that, if you remember, for convection, we said that providing turbulent flow will increase the amount of heat transfer in convection method very huge amount, okay? That's why they prefer to have this method of passage by providing baffle, and we will see the configuration of baffle. By installing a baffle, the fluid available in the shell is going to pass through the tubes in cross-contour or hybrid or mixed. You can find all of these different names in the references, and this will increase the amount of heat transfer. Okay? So by checking the formulas and knowing the different type of flow direction, we can understand which one is the most effective one. And when we are talking about effectivity, is actually energy consumption. Okay?